Alright, we're going to solve this inequality, then we will graph the solution set, and finally we will write this in interval notation. And you can treat the inequality sign as an equal sign unless you multiply or divide by a negative number, in which case you have to flip the inequality sign. Okay, so first let's go ahead and solve for x. We're going to want to get rid of these parentheses. So we'll distribute our 3 into each term. And then, sorry, inequality sign doesn't look too good. Let's see if we can make that more like inequality. Then we'll send in our -6. We're distributing that. -6 times -5. And bring down our +14. Okay, we're going to be able to combine like terms on each side of the inequality. So the 12 and -4 combine to give us +8. X drops down. And here the 30 and the 14 are both positive, so that's +44. Bring down your -6x. I could get rid of any one of these 4 terms, but I'm going to get rid of the -6x because I don't want to have to deal with a negative. So a positive, it's held here by addition or subtraction, so I get rid of it with addition or subtraction using the opposite sign. So +6x and +6x. Getting a little crooked here. So there's 9x. That's a 0. I don't have to write it. Bring down the 44, and I don't have to put positive there. Let's get rid of that 8. And one more step. You have to get rid of the 9. Divide by 9, divide by 9. Zoom out for a second. Well, we might stay zoomed out. And 9 goes into 9 once, so you're left with x is greater than 4. Okay? So for our first step to solve the inequality, we've done that. Okay? And now they want us to graph the solution set. Alright, let's graph the solution set. So we'll give ourselves a number line here. I think I'll put it up here. And since 4 is involved, I'll center my 4 and then have 5, 6, 3, 2. And let's see. X is greater than 4. It's not allowed to touch the 4. That I have to use the parenthesis at this position. I cannot use the square bracket. Okay, that means it's allowed to touch the 4. It can be equal to 4. But that is not the case. So I use parenthesis. And x is greater than 4, so that means it could be a 5, a 6, 4.5, 700, anything. As long as it's greater than 4. So you fill in to the right. Okay, so now we've graphed it. And then the last thing they want us to do is write it in interval notation. Okay? So you might find it easiest to go from the graph to interval notation. X can be anything greater than 4, so it goes all the way out to positive infinity. I should say towards positive infinity. You can never touch infinity. Anyway, interval notation is right here. We'll take a look at another one that's a little more complicated. Notice you have two inequality signs. All right. You will be solving this as you have before, though. It just looks a little more complicated. We're going to go through the same process. We'll solve it, we'll graph the solution set, and then we will write it in interval notation. I'll zoom in on this a little bit more, though. Okay. Just as with the algebra problems, you decide what you want to get rid of, and then you use the opposite. You decide how it's held there, and you use the opposite operation to get rid of it. I want x all by itself. I want to get rid of that -5. I want to get rid of the 2. As usual, it's best to get rid of something being added or subtracted first. So this -5 is held with addition or subtraction. I'll get rid of it with addition or subtraction. So I'm going to say a +5 right here in the middle. I'll put a +5 on the right, and I'll also put a +5 on the left. Okay, so notice I have to indicate this in 3 different positions. And then we'll draw a line here. Maybe I'll zoom in a little bit more. And bring down what we have. So the 1 and the 5 combine to give us a 6. This stays the same. Alright, sorry it's a little bit crooked. We have a 2x remaining in the middle. That 5, -5, +5, that's a 0, so I don't have to write it. Bring down the other inequality sign, and a +5 and a +5 yields a +10. And we have one more step now. We need to get x by itself. We want to get rid of the 2. It's held by multiplication. The opposite operation is division. So you divide by 2, divide by 2, and divide by 2. 6 divided by 2 is 3. Inequality sign comes down. 2 divided by 2 is 1. So you have x. Inequality sign comes down. And then 10 divided by 2 is 5. Okay? So they said solve the inequality, and we just did right here. All right? The next step is to graph the solution set. Okay, so we'll give ourselves a graph. And let's see, I need to get a 3 and a 5 in here, so I'm going to have a 2, 3, 4. Looks like I'll fit a 7 in there as well. Okay, I've heard people read these different ways, but I suggest you start from the middle. Okay, x is greater than or equal to 3, and x is less than or equal to 5. Remember, start from the middle. So x could go all the way down to 3. It's allowed to touch it. That means I can use the square brackets. It can go, x can go all the way up to 5. Again, I can use my square brackets. And then I'm to fill in everything in between. So we've graphed the solution set. Oh, I'm sorry, you couldn't see what I was underlining up there. So we've graphed the solution set. All right. Earlier we solved the inequality. And then the last thing they want us to do, I'll zoom out for this. They want us to write this in interval notation. Again, you might find it easiest to go from the graph to the interval notation. X goes from 3 up to 5. So there's our interval notation. We're going to look at one more that's a little bit more complicated. And notice you have, I'll zoom in a little bit. It'll be the same request that we solve the inequality, graph the solution set, write it in interval notation. But I'm going to zoom in a little more to really focus on this problem. Okay. To solve the inequality, we can actually go about this two different ways. Most of the problems, or all of the problems that you've solved so far, if you had a value outside the parentheses, you would distribute it in to each term to get rid of the parentheses. But the two values that I want to get rid of, I want to get rid of the 5 and I want to get rid of the 3. So the easiest thing to do is going to be get rid of this 5 first. Okay? This is usually we get rid of things that are added or subtracted first, because in general that's easier. But in this case, the 5 is going to be easy to pluck off, so to speak. Okay, the 5 is held there by multiplication, so I'm going to get rid of it with division. So I will divide by 5. I have to do the same thing in all 3 positions. Okay. When there's just an equal sign or one inequality, you do the same thing on each side. But now, it wouldn't really be right to say each side. You have to do the same thing on all sides. Divide by 5 and divide by 5. So 5 goes into 25 5 times. This inequality drops down. 5 goes into 5 once, so I don't even need my parentheses anymore. I just have x plus 3. This inequality drops down, and 40 divided by 5 is 8. Now we just want to get rid of the 3. So we have a 2, we bring down our inequality sign, we bring down our x. This is a 0, I don't have to write it. Bring down the inequality. Oops. And there's a 5. Okay. So they said solve the inequality, and we just did. This is the solution. For the next request, they said graph the solution set. So we'll give ourselves a graph, and we'll make sure we have a 2 and a 5 in there. And to graph it, again, read from the center. That's what I suggest. Not everyone does this, but I think it's the best practice. X is greater than 2. It's not allowed to be 2. It doesn't touch it, so we have to use our parenthesis. And X is less than or equal to 5, so that would be a bracket. There's a train going by outside, so sorry about that rumbling noise. Yay for commerce, though. Alright. So you fill in all the values, okay? So they said graph the solution set, and we just did. And then the last thing they want us to do, let me zoom out. Well, it's hard to fit that word. But they say write it in interval notation. You might find it easiest to go from the graph to interval notation. Two comma 5, and this is our interval notation.